Hi there, welcome to SS 6.5. This is my first video where I'm on video, so here we go. In SS 6.5 you are to demonstrate an understanding of single and combinations, which would be two or more, of different kinds of transformations. And you learned in one of the grade 5 outcomes that transformations are translation, rotation, and reflection. So remember those three things. And so in this outcome, it says you're supposed to identify it, to be able to say, oh, that is a rotation, or that's a translation, or whatnot. Describe it, be able to tell that they moved it 2 spaces down, 1 space over, or they rotated it 90 degrees clockwise or counterclockwise, and be able to perform it. So if I give you the instructions, that you can actually do the transformation. So let's look at our first outcome here. Get my pen going. Observe and classify different transformations found in situations relevant to self, family, or community. They always have that one that's relevant to self, right? So if you're moving furniture, you might decide you want to rotate your dresser 90 degrees clockwise. That would put it on the other wall in your bedroom. So there's lots of places where it's relevant to self. A lot of artwork has to do with transformations. B says to model the translation, rotation, or reflection of 2D shapes. So being able to draw it with a pen. Analyze 2D shapes and their respective transformations to determine if the original shape and the transformed shape are congruent. So congruent means, where's my pen going to end up here? Right over here. Congruent means same size, same shape. So it might be in a different location, but it's exactly the same measurements and it's the exact same shape, same sides, all that jazz. So that is congruent. Determine the resulting image of applying a series of transformations upon a 2D shape. So if we're doing a series of transformations, that means more than one. So you might have to follow step by step to see how that goes. Describe a set of transformations that when applied to a given 2D shape would result in a given image. So as you can see, there's, well, all the way from A to M here, there's a lot of indicators. We only need to be super confident with 3 or 4 of them. So a lot of these say kind of the same thing, just doing it a different way. So if you can tell about the transformation, if you can actually perform it, if you could model it, if you could do artwork, it's all the same skill, just showing it in different ways. Identifying situations, designs with situations relevant to self. So I actually have some designs coming up in one of the slides. Analyze a given, where am I? Create a design using the transformation of 2 or more 2D shapes and write it or record it orally or give instructions that could be followed to reproduce the design. So think about going on a hunt for treasure. You might tell the person that they have to go 4 spaces to the north and then 5 spaces to the east. So that's basically doing a translation, a slide. Describe the creation and use of single and multiple transformations in First Nation and Métis lifestyles. And the one they've given here is birch bark biting, but we're actually going to look at beadwork. Identify the coordinates of vertices. Now, vertices are the pointy parts. One of those. So any of the corners. And coordinates, that's on the coordinate plane. So you've got your x-axis, which is this one, and your y-axis, which is this one. This is vertical. And being able to plot out the points on the Cartesian plane, that's kind of one of those prerequisite skills. Perform a transformation on a given 2D shape and identify the coordinates of the vertices. When you have one vertex, one corner, it's called a vertex. When you have more than one, it's called vertices. It's like mice and mouse. Describe a transformation of a 2D shape shown in the first quadrant of the Cartesian plane that would result in the image of the 2D shape also being in the first quadrant. So we will get on to that. Let's go to our next slide. Okay, so remember I was talking about the x-axis and the y-axis, so you can see them labeled here. You always plot the x-axis first. This guy is first. So if you are, let's look at our blue triangle here. if I draw this nice green dot on the vertex, one of the vertices, let's figure out where that green dot is living. So if we're going to plot the x-axis first, we start at the origin. I'll just change colors here. We start at the origin, and we're going to move out on the x-axis. So are you ready? 1, 2, 3 jumps, right? But it's 3 jumps to the negative side. So our first point would be -3, and then it's 2 jumps up, so we're going positive on that one. So comma and then 2. We put them in brackets, and these are called ordered pairs, which is a great name for them because they do have an order. The X guy has to go first, and there's always a pair of them. You couldn't just plot one point because you wouldn't really know where to put that on your coordinate plane. So remember that green dot, and he is living at -3, 2. Super duper. So now, what if we want to move him? You will notice in the upcoming slides that when they move a shape, it's not called the shape anymore. It is now called the image. So if it was looking at itself in the mirror, that's not you inside the mirror, that's just your image. I hope you knew that, right? Okay, so if I'm going to put this blue triangle in a mirror, let's say that our mirror is right here. Look at that nice straight line. Whew, yeah, it's good. Okay, so that is my nice straight line. That's going to be our mirror. So if that blue shape was looking at itself in the mirror, it would go something like this, right? And so now this is now called the image. I-M-A-G-E, image. Usually the points on the blue triangle would have a name. They would maybe call it point X, point Y, and point Z. Okay, now I want you to look on the next slide and see if you can tell which one is the original shape and which one is the image. And it has something to do with the way they've labeled those vertices. So let's have a look. Okay, looking at these pink triangles, over here we have triangle ABC, and it says that each vertex has been slid 6 units to the right. And so they took point A right here, and they're going to slide it. 1, 2, 3, 4, 5, 6. Now, this guy is the image, right? How did they label point A on the image? Do you see that tiny little number 1 that goes with the A? Right there. See him? So A was the original point, and when they moved it, now it becomes A1. So you can always tell which shape is the image because it's got that little 1. So be on the lookout for those guys. And so these pink triangles have been slid. So if we slid point A 6 spaces to the right, we better do the same thing to B. 1, 2, 3, 4, 5, 6. And C, same thing. So they've taken that whole image and they've translated it, which means slide, 6 spaces to the right. Good? Okay, let's look at these maroon colored polygons. I guess they would be quadrilaterals. They have 4 sides. So, can you tell which one is the original shape? Yes, you can, because it is just labeled A, B, C, D. The image is over here, because you can see that little tiny 1 right there. Okay, so it says this figure has been slid to the left 7 units and then down 3 units. So let's look at, I'm going to change my color here, let's go yellow. Let's look at D. So here was the original point of D, and it says it went 7 to the left. Okay, ready? 1, 2, 3, 4, 5, 6, 7. And then it also went 3 units down. 1, 2, 3. So there's D1. There's the image. So sometimes a transformation, such as a translation, a slide, or a rotation, a turn, or a reflection, a flip, sometimes they can have more than one step. So in this particular example, they told you to move it over and then down. Let's look at our next guy. Okay, so you could describe these orange triangles in a couple of different ways. If we labeled, let's just grab a different color. If we labeled this top triangle, now you'll notice these ones don't have any labels, and so you can't tell which one is the image and which one is the shape. So let's just name this one. Let's call this point A, point B, and point C. Okay? So you could do this in a couple of different ways. You could say that they turned the shape, they rotated it, and then they moved it down, and then they moved it over. So this could be done with a rotation of 90 degrees, and then slide it down a few spaces, and then slide it over a few spaces. So they could do it that way. So if we were going to list the instructions for that, we could say from point, we're going to flip point A, we're going to turn, let's see, we're going to turn it 90 degrees. So point A is going to go clockwise all the way up to this line, right? Which then would make it look like this, right? Which is kind of similar to that bottom triangle that they have down there. And then they must have moved point A down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a little bit. So that one's tricky. So they moved it down a bit, and then they moved it over. 1, 2, 3, 4, 5. So you could do it like that. Let's change colors, and I'll show you a different way. Sometimes when you have a rotation, let's look at this guy over here. When you have a rotation, I could start at point P right there, and I could just take that shape and just twist it over. And point P kind of has like a pin in it. It's not moving. And so I can spin those triangles all the way around point P and keep them rotating. So in this case, I think the blue triangle was the shape, and the red triangle is the image. Let's see how my printing is on an angle. Nailed it. All right. So you see the gray arrow, it's going counterclockwise. So you can see that they started here and they went all the way around to there. And they said that was 90 degrees because if you took this line and this line, you can see that that's a nice square corner, if I can draw. Nice square corner in there. So that's 90 degrees. So they took that shape and they twisted it 90 degrees. So you can do that with a pin on point P on one of those vertexes. So if your vertex doesn't move, you can spin that shape whatever direction you want all day long. But you can also do it where your vertex is not pinned down. So let's go back to the orange triangles. If I picked a center point, let's say maybe it was the origin, which is point 0, 0 right here where the green dot is. If I rotated my shape around there, pretend that triangle is on a little string from the origin. And I took that triangle and moved it over here. And so it's still on that same amount of string, and I've still rotated it 90 degrees, right? Because that's a 90-degree angle right there. But my point of rotation is the origin, which is point 0, 0 right there. Origin. Okay. So sometimes you can rotate it on a pin like we did over here with point P, and sometimes you can rotate it around a point like 0, 0 is what they've picked there. All right, last one. This is the reflection. And so the blue triangles, that was kind of like the first example that we did where it's looking in the mirror. And these ones aren't labeled, so you can't tell which one was the shape and which one was the reflection. In this case, the mirror, which is the axis of symmetry, which sounds pretty fancy, but that's all it means, is what line are they using? Axis of symmetry. I hope I spelled that right. Okay, so they've used the y-axis, that vertical line, as their axis of symmetry. So if you look at this point here, it was one space to the left of the axis of symmetry, and so when they did the image, they moved it one space to the right, and they flopped it over like that. Let's look at those orange, what are those called? Rhombuses? I think so. They have a different axis of symmetry. So the original shape, did you figure out which one is the original? Got it? Okay, so let's look at point M right there. It doesn't have that little number 1 beside it, so that is the original shape. And M ended up way down here. So it wasn't just a slide. They've flipped that thing right over. And it wasn't just a turn, although you could say it rotated around the origin just like that other guy did. Or you could say it was a reflection, just like a mirror, on that line. That one is pretty straight. I'm getting better at this. It doesn't go through the origin, but yeah, it's close. Okay, so pretend that green line is the mirror, and they had one shape up in the top quadrant, and they flipped it down into that bottom quadrant. So that one is kind of cool, but you can see that it is one space over and one space up. So they went one space over and one space down, kind of doing the opposite. So if you wanted to find where should A go, or A1, well, let's look where the original A was. On the x-axis, I'm going to change colors here while we go hunting for A. It's 1, 2, 3, 4. So we went 4 on the x-axis. We always do the x-axis first. And then we had to go 1, 2, 3, 4. So A is at 0.44. Okay, so then where is the new and improved A going to be? Well, technically, you just have to think of what is the opposite. What's the opposite of 4? It would be -4 and -4. So let's count that out just to make sure that we're right. Starting at the origin, which axis do I do first? X or Y? I'm hoping you're saying X. Okay, so we're going to go -4. 1, 2, 3, 4. So far, so good. Now we're going to go down 4. 1, 2, 3, 4. We found it. So there is A1. That's our image. Last slide. Okay, so here's some very cool artwork done by First Nations people. And this is a really good example of transformations in real life, and it's so pretty, and it's really, really cool. And it's a lot of work. So let's look at this funky bracelet. Lots of different colors. If you were trying to pick where to put these things and plan out your design, you might say, well, I want this blue triangle right here, or turquoise triangle, I want it to move down 1, 2, 3, 4, 5 spaces, and over 1, 2, 3, 4, and that's where I want the vertex to be. And then they start the triangle again. And I'm going to go down 5 more spaces. 1, 2, 3, 4, 5, and 1, 2, 3, 4. Same thing. So they used math to get their design to be just perfect. It's pretty cool, isn't it? So how did they make these bead things? Well, let's look up here at this thing, which is called a loom. Okay, a loom has a bunch of strings. You can see these white strings that are going this way. Okay, when you have, where's my pen? It really likes purple. There, I have white. Yay. Okay, so there's strings and they're stretched from both of those end pieces, these guys right here. And those never move. They stay stretched out like that. And they don't have beads on them. So then they take, you can see he's got a needle and thread, and they put the bead on the needle and they go under one string and over one string and over one and under one and over and under. And they keep putting beads as they go, and that's what makes the beads go on the pattern going this direction. So pretty complicated stuff, and you'd have to plan it out beforehand to get your design just right. So if you're ever doing any bead work at home, because lots of us have beads at home, try some of that and see how you do. And you can make me some mittens because I really like these ones. They're pretty cool. All right, thanks for watching.